In this video, we're going to be tackling the LeetCode question, best time to buy and sell stock. If you are familiar with the stock market, it is a pretty simple concept to understand. You want to buy low, you want to sell high in order to achieve the maximum profit. And with that in mind, if we take a look at this stock chart right here, where would we buy and where would we sell in order to achieve the maximum price? Well, we would buy right here at the very bottom. We would sell up here at the very top. This is a nice little stock chart that makes things easy for us, but LeetCode is going to give us the data in the form of just a very plain looking array. There's nothing stock market about this array, so maybe if it helps you put some dollar signs on it, or you could translate this into a nice little line graph as I have done. So if we have a nice little chart, we can kind of just eyeball it. We don't need any fancy algorithm. We can just take a look right here and say, well, here's the lowest point. Here's the highest point. This is the maximum profit. And you would be right, except we still have to translate this into an algorithm. How exactly are we going to do this? Well, first way, and hint, the not good way, is we could use brute force. So in order to solve this question using brute force, what we would do is we would create a nested for loop. We would set a pointer right here, we would set a pointer right here, and we would just iterate through every single possible combination of values, just like this. So we'd set one pointer at 7, one pointer at 1, iterate through all of these values, move the first pointer up, repeat the same exact process. And this is how we would go through every single combination. But the bad side is that, number one, this is very high time complexity. And number two, we're going through so many unnecessary iterations. There's so many unnecessary iterations going on because we're calculating every single stock price. What we need to do is we just need to cache the lowest price in a variable and use that lowest price in order to calculate the highest price. So this is going to work in 3 phases. Obviously, this is an algorithm, so we are going to need a for loop. And what we're going to do is we're going to initialize a for loop at the second element. We don't need to start at the first element. We need to start at the second because at the first element, there's no days to actually calculate. Second thing is we're going to cache the minimum price. Now, caching sounds like a fancy word, but caching pretty much means a variable where we're going to store the minimum price. It's just going to be an integer. The next thing is that we also need to cache the maximum profit. If we obtain the maximum profit, we want to keep it and we want to prevent ourselves from doing all types of unnecessary calculations. So we're also going to cache the maximum profit. Now, let's go ahead. Let's simulate how this is going to work. So for our first iteration, we are already at the minimum price, the lowest possible price that we can ever achieve throughout this whole entire algorithm, which is going to be 1. The second max profit is a different case. It is actually going to be -6, which, as you can imagine, this max profit is definitely going to change. Let's go ahead. Let's iterate to the next value. Minimum price is not going to change because the minimum price is 1, but the maximum profit is definitely going to change. And 5 minus 1 is equal to 4. And we're going to do the exact same thing, but the maximum profit is not going to change because 3 minus 1 is equal to 2. But once we get to 6, this is where things are going to change again because the maximum profit is now going to be 5. And once we get to 4, the min price doesn't change and the max profit doesn't change because the max profit is indeed 5. And that is pretty much it. So let's go ahead, let's hop into IntelliJ and let's start coding it. So we are inside of IntelliJ, and first thing that I'm going to do, as usual, is create a brand new Java class. We will call this solution. Next thing, we will create the method. It's going to return an int. We will call this max profit, and it's going to take in an integer array of prices. We will then do a nice little null check, and we're going to do a null check so that if null is passed, we definitely don't want this to run. And if we pass in null, it's going to kill our speed. So we want to check that beforehand. Let's go ahead and declare some state. We're going to have to store our minimum price because we're going to cache it. Also, we never want to put 0 right here, because if you put 0 for the minimum price, that's going to automatically be your minimum price, and it's going to kill your algorithm. We also need to calculate the profit. This is actually what we're going to return, and we can actually set this to 0. Let's go ahead and create a for loop, just a regular for loop, nothing special going on here except that we're going to start at the second element, so make sure that that is a 1. And we're going to go ahead and create the code that's going to store the minimum price. And the way that we're going to do that is we're going to use math.min. We're going to pass in the minimum price, and we're also going to put in the second parameter the current price that we are at within the array. Next thing, we need to calculate the profit. Thankfully, the AI is going to do most of it for us. And remember, the profit is basically the price that we are at currently minus the minimum price. And that is pretty much it. We'll go ahead and return the profit. Go ahead, save this. I'm going to copy all this in here, get out of full screen mode. Let me pull up LeetCode really quick so we can check the time complexity. So let's go ahead, pull up the LeetCode editor. We'll toss this into here, bring that over so it looks real nice. Let's run our test cases, see what we get. Everything is passing. Let's go ahead, hit that submit button to make sure that we have good time complexity and space complexity. So our runtime complexity is, boom, linear. And our memory is constant. We are doing great. We have passed the interview. Congratulations, guys. If you like this video, make sure to smash that like button, smash that subscribe button. And as always, thank you for watching.